What's happening, y'all? What is happening? Pastic back with another video, and in this one we're going to be talking about rational numbers again. And our objective at the end of 2.6 is to be able to calculate theoretical and experimental probabilities of single events. Let's do it. So a bowl contains 12 slips of paper. It is a weird bowl, each with a different name of a month on it. Find the theoretical probability that a slip selected at random from the bowl has the name of a month that ends with brr. So we need to find the probability of one of these slips is going to have a name of a month that ends with brr. So we got to list out all the months. We got January. Does that end with brr? No. February. Does that end with brr? No. What's next? March. Is that a brr? Nope. January, February, March, April. You got a burr there? Nope. May. Nope. June. Nope. July. August. September. Oh yeah. October. Oh, big time. Yep. Oh yeah. November. Oh yeah. Yep. And December. Those are the 4 months that end with brr. So, how do we find the theoretical probability that a slip selected at random, this is important, if it's not random we can't do this, from the bowl has the name of a month that ends with brr? Well, we know that there are a total of 4 that end with brr. So, 4 out of how many? 4 out of 12, I would say. So theoretical probability, any probability, boils down to number of ways a specific event can happen that is number of ways a specific event can happen divided by the total number of possible outcomes. So in this case, how many ways can our specific event happen? How many ways can we pick a slip that ends with brr? Well, there's only 4 ways because there's 4 months. 4 out of how many? How many total possible slips could we pull? There's 12 possible slips because there's 12 months. So our theoretical probability is 4 out of 12, but we can reduce that. We can divide by 4 up top, divide by 4 on the bottom, and we get 1 out of 3, or 33.3 repeating percent. I prefer 1 out of 3 as a probability, and that is your best answer unless they ask specifically for something else. For a number cube, find the probability of not rolling a number divisible by 3. So we want to know what's the probability that we roll a number that is not, we want to know the probability of not rolling a number divisible by 3. So is 1 divisible by 3? No. Is 2 divisible by 3? No. Is 3 divisible by 3? Yes. Is 4 divisible by 3? No. Is 5 divisible by 3? No. 6? Yes. So there are 2 numbers divisible by 3 on a number cube. A number cube, I don't know if you figured that out, is basically the same thing as a die. So what is the probability of not rolling a number divisible by 3? Well, that means what's the probability of rolling a 1, 2, 4, or 5? Those are all the numbers that are not divisible by 3. So remember back to the last slide. Our probability, our theoretical probability, is going to be calculated based on the number of ways this specific event can happen. How many ways can we roll a number that is not divisible by 3? Well, there are 1, 2, 3, 4 numbers not divisible by 3, so 4 on top, over how many total possibilities are there for a die when you roll it? There's a 1, 2, 3, 4, 5, 6, so 6 possibilities. 4 out of 6 is our probability. Let's reduce it. Divide by 2. Divide by 2. Probability of 2/3. The other way you could have done this one is you could have found the probability of rolling a number divisible by 3, and then basically subtracted that from all the other possibilities. But we'll leave that for another discussion. Find the odds. Odds is the same thing as probability for the spinner below in favor of the spinner landing on an even number. So what is the probability that this spinner lands on an even number? So if I look at the spinner, it appears to be 8 even sections, 8 equal sections. All these sections seem to be about the same size. That's important. If they aren't the same size, then we have to do more thinking. It's a lot harder. What's the probability we landed on an even number? Well, how many even numbers are there? We got a 2, we got a 4, we got a 6, we got an 8. So there are 4 possible ways for this event to happen. How many total ways could we end up on a spinner? Well, basically, there's 8 sections, 8 different numbers, 8 different outcomes. So our probability of landing on an even number is 4 out of 8. And again, we want to reduce. We can divide by 4 this time. You always want to look for the highest number that is going to be a factor of the 2 other numbers. So 4 goes into 4 and 4 goes into 8. So 4 divided by 4 is 1. 8 divided by 4 is 2. Our probability is 1/2. All right, y'all. Don't know what I said last, so on to the next one. Quality control inspected 500 belts at random. Again, we're using this word here at random. That means everything has an equally likely chance of being selected. They found no defects in 485 belts. So 485 out of the 500 had no defects. What is the probability that a belt selected at random will pass quality control? If it passes quality control, that means that it has no defects. In order to pass, it will have no defects. So we got to figure out, again, now this one is called an experimental probability. It's called experimental this time because it actually happened. This is something that they actually did. They experimented. They took 500 random belts, tested them all. They found that 485 of them had no defects. So the question is, what's the probability that a belt selected at random will pass quality control? So number of passing belts divided by the number of total belts is going to be our probability. So the number of passing belts is 485, and the number of total belts is 500. So we could reduce this. We could reduce it by dividing by 5 on both top and bottom. And that is going to give us, looks like 97 over 100. So that is our experimental probability. Again, experimental because it actually happened. Theoretical is just based on a logical construct or idea that could happen. It has not yet happened, but it's based on what should happen. So theoretical is what should happen. Experimental is what actually happened. If the belt manufacturer from additional example 4 has 6,258 belts, predict how many belts are likely to have no defects. Well, we know that, according to the previous page, 97 out of 100 was the probability to have no defects. So we can use that as a ratio to set up a proportion. If we know 97 out of 100 have no defects, and now we're looking at 6,258 total belts, we want to predict how many belts are likely to have no defects. So we're going to set up 97 over 100. This is no defects over total. No defects over total. And we want to do the same thing over here. So how many will have no defects? We don't know yet. X equals number of belts with no defects. How many of these will have no defects out of a total of 6,258? Well, we have to solve for x here. So in order to solve for x here, we need to get rid of the 6,258. And seeing how x is being divided by 6,258, we are going to multiply by 6,258 on both sides. So we're going to cross those out, and we're now going to find out what x equals. So x equals 97 over 100 times 6,258. And for something like that, we are going to use a calculator. And we're going to find out that is 6,070.26. So the question is, how many are likely to have no defects? We're going to answer that with a sentence. 6,070 belts are likely to have no defects. All right, y'all. That's it for this video. Section 2.6, Experimental and Theoretical Probabilities, is El Dunzo. Hope you learned a little bit. Catch you next time.